All right, welcome to our notes on parabolas and how to move these around. So, you just did a lesson and you saw that we could move parabolas around. And so, now what we're going to do is summarize all this information in one spot. So, we're going to first start out with the graphing form of a quadratic equation. Remember, quadratics are what makes a parabola. So, our graphing equation, and this is something you will need to know, but we will use it so much that it'll probably come second nature. The equation is y equals a, parenthesis, x minus h, quantity squared plus k. And our variables are, as always, x and y. So remember, input variable, exput, output variable, they don't change the way the graph looks. It just changes and gets you points on the graph. Where if we look at the parameters are what are changing the graph. And if you noticed, when you did your activity, if you changed the a, which is in the very front, it changed the graph. If you changed the h, which was inside the parenthesis, added or subtracted the x, it moved the graph. And if you added or subtracted something at the end, which is the k, it physically moved the graph. So those are our parameters, the h and k, and they actually are what move the graph or change the graph. And in this case, our vertex is always the point h comma k. And as we're going to see, the h is what moved it left or right, the k is what moved it up or down, and so that's moving our vertex. So to make the graph of y equals x squared move up, we can make the k positive. And again, the k is what's added at the end. So it's going to look something like this. Y equals x squared plus 2. So if we add something at the very end, that's going to move the graph up. If you look, this dotted line is our parent equation, the y equals x squared. So I would have the same shape and size parabola. It's just going to be moved up 2. The vertex would be at 2. All right, we can also make the parabola move down. So to make the graph of y equals x squared move down, you can make, again, it's still going to be the k value, make the k, but now negative would make it move down. So k kind of works the way you think. A positive moves up, and a negative is going to move down. So if I did y equals x squared minus 2, that would move the graph down too. So it'd be the same parabola, just move down 2 units. We can also make our parabola move left and right. So to make it move to the right, that is going to be our h parameter, the parameter that's with the x. So the way I remember it, whatever's with the x moves it left or right. Remember, your x-axis goes left and right. So the h is with the x goes left and right, h is what moves it left and right. Now the tricky part here is the a is what the opposite of what you see, because in our equation it's x minus h. Okay, and I'll talk about that right now. So what we're actually going to do to make the h, to make it move right, we can make the h, again, positive to the right is positive, is right is to the positive. So we are going to make the h positive. And that makes sense because right is positive. However, the confusing part is that it will look negative in the equation because the equation is x minus h. So for example, if I want to move it right 2, our h would be positive 2. And when I go and I plug that in to x minus h quantity squared, I'm plugging a positive 2 right in there. So the actual equation would be x minus 2 quantity squared. So that's why I'm saying it looks the opposite of what you see in the equation. It looks like a minus 2, but I actually plugged a plus 2 in because that negative was already part of the equation. So now the vertex would just be moved 2 units to the right, and the whole parabola would be moved 2 units to the right. All right, next page then. To make the graph of y equals x squared move left. That is still the h parameter. So we can make h, and again, left is negative, so we're going to make the h negative. But again, it's a little confusing because it's x minus h in the equation. It will look positive in the equation. So, for example, if my h is going to be negative 2, and my equation again is x minus h quantity squared, then what I would be doing is I would have x minus a negative 2, and the double negative makes it positive. So it would be x plus 2 quantity squared. That would be our equation. So again, the actual h value is negative 2, which makes sense, but it's going to look positive in the equation, which is a little bit confusing part. So this would be the same parabola, just everything moved left 2. All right, a couple others. We can make the graph of y equals x squared flip or open down. Same thing. That was the a parameter, and we make the a negative number. So, for example, we could just have y equals negative x squared. Again, a is in the very front. And so that would just flip the parabola or make it open down, meaning the arrows point downward. The A can also make it a little bit thinner or wider. So we make these a little bit different wording. So to make the graph of y equals x squared, we're going to call it vertically stretched. So if you think about a rubber band, if you stretch a rubber band vertically, pulling it top bottom, that rubber band gets skinnier or thinner. So this is the skinnier one, as many of you may have described it when you did the activity before this. And the way we make that parabola vertically stretched is to make the a value greater than 1. Now, we're going to worry about the absolute value of a being greater than 1, because I could also flip it and make it vertically stretched at the same time. So we're just looking at the absolute value of that. If the absolute value of the a is greater than 1, then it would be vertically stretched. So for example, I could have y equals 2x squared. My a is 2 here. The absolute value of 2 is 2, and that's greater than 1, so it would be vertically stretched. I could also have negative 3x squared. So the absolute value of negative 3 is 3. 3 is greater than 1. So therefore, this one would be flipped because the a is negative and also stretched. But if we're looking at just graphing the y equals 2x squared, a skinnier or a vertically stretched one means that it's just going to grow faster. It's going to look something like this. And then the last one is vertically compressed. So if you ever took a pile of Play-Doh or clay and you push down on it vertically, the Play-Doh or clay pushes out, and that is vertically compressed, which would mean wider. So to do that, it's still the a value, but we're going to make the absolute value of a be between 0 and 1. So less than 1, but greater than 0. And again, we're worrying about the absolute value because we could also flip it and vertically compress at the same time. So for example, if I had y equals 0.5 x squared, The absolute value of 0.5 is 0.5, which is between 0 and 1. So that would be vertically compressed, which means wider. So it would be the same U shape, but just out a little bit wider, growing a little bit slower. Now I could also do y equals negative 1/3 x squared. So the absolute value of negative 1/3 is 1/3. So that's why it's vertically compressed. But the negative is also flipping it. So this one would be compressed and flipped at the same time. So refer back to this when you get a chance. If you need help, this is a good tool for you to look back at how each of the parameter changes the graph.